Did you know the world's most expensive and dangerous tunnel was built by cutting through massive mountains, where every step could cost lives? But how did engineers survive extreme pressure, heat, and darkness to complete this impossible project? And what secrets lie deep inside it? Water explodes through the wall. Without any warning, hidden pressurized water bursts through the tunnel wall at jet force, flooding the entire section within seconds. Engineers had unknowingly drilled into a catastrophe. The world's most extreme tunnel, Switzerland's Gotthard base tunnel. 57 kilometers long, 2.5 kilometers below the mountain surface, the longest and deepest railway tunnel ever built in the history of human civilization. Inside this mountain, four forces were waiting: crushing rock, temperatures of 50 degrees Celsius, hidden water at 2,900 psi, and rock walls that exploded without any warning. Everyone said it was impossible. The world's greatest engineers declared it impossible to build. The machines would destroy themselves. Workers could not survive. Two drilling teams would never find each other inside the dark mountain. 17 years. 2,600 workers. 9 deaths. Workers walk through the tunnel for shift change. They step into gate closes. Into the mountain. Why did Switzerland even try this? Before we go underground, we must understand what forced Switzerland to attempt something the entire engineering world believed was physically impossible. It starts with a mountain range. The Alps, Europe's Great Wall. The Alps stretch 1,200 kilometers across the heart of Europe, an almost impenetrable wall of rock and ice that has blocked the movement of people and goods for thousands of years. For centuries, the only routes across the Alps were treacherous zigzag mountain roads. Snowfall closed the passes for months each winter. Avalanches ended journeys and lives without warning. Railway lines were built over the Alps, but the steep gradients meant trains crawled upward, burning enormous power. A journey that should take 1 hour stretched to 4 hours or more. By the 1990s, Europe's economy needed massive daily freight movement between German factories and Italian seaports. The Alpine mountain barrier was strangling an entire continent's trade network. Every year, over 1 million heavy trucks grind through Alpine villages, shaking buildings, poisoning the air, and cracking roads. Switzerland's mountain communities are being slowly destroyed by this transit traffic. On September 27, 1992, the Swiss approved the project. Switzerland would drill straight through the heart of the mountain. The Gotthard base tunnel would redefine Swiss infrastructure. Engineers had two choices only: build wider roads over the Alps, already beyond their limits, or drill a tunnel that would be longer, deeper, and more dangerous than anything ever attempted. 57 kilometers of tunnel through solid Swiss granite. Equivalent of drilling underground from a millimeter vision. Real footage, engineers and surveyors at work. Two teams drill from opposite sides of the mountain. If the alignment is off by 1 centimeter over 57 kilometers, the tunnel's myths, these are gyro a lot. Precision technology guides them. The tunnel was so long that engineers had to calculate the curvature of the Earth into the alignment mathematics. Ignoring Earth's curve would cause a final missurvey maps and carrier sheets to make the correction. The TBM, half a kilometer of machine, to cut through the mountain. 4 Herinet gripper TBMs were built, each 441 meters long, the largest drilling machines ever assembled in human history. Inside the TBM, a moving factory, control bins, conveyor belts, stang erectors all advance the operative monitors progress. Volcanic arms erect the tunnel lining. Workers oversee the systems, propelling the machine forward runs. Only 30 meters per day. Through hard granite, the TBM advanced just 30 meters per day on a good day. Through the most resistant rock sections, it slowed to just 2 meters. 90,000 parts, $21 million each. Each TBM consisted of 90,000 individual parts and cost 21 months just to assemble one machine inside the mountain. And it could never be brought back out whole. At peak construction, 2,600 workers were underground simultaneously, sleeping, eating, and working the clock, 365 days a year for 17 years. Real footage shows the workers' daily life. Inside the mountain, engineers built a complete underground transport network to move workers and materials deep through tunnels. Electric rail vehicles, buses, and elevators form the backbone of this vast subterranean infrastructure. As the TBM pushed deeper beneath the mountain, the surrounding rock began releasing geothermal heat. 30, then 40 degrees Celsius, still black. At 2 kilometers deep, the rock temperature hit 50 degrees. The tunnel became an oven. Workers could only function safely for heat stroke when they a short check by a medic. As fans run at full power, the TBM electronics began failing in the extreme heat. Hydraulic oil overheated. Bearings seized. The most powerful drilling machine was being destroyed by the problems for a wharf. Engineers installed a massive cooling pipeline system, pumping chilled water from refrigeration plants at the surface deep into the tunnel, bringing the working temperature down to survivable levels. Gotthard, the world's first cooled construction site. Engineers built a climate system before any work began. Cool the environment first. No alternative. 2-hour maximum shifts at the face. Workers emerge exhausted, soaked in sweat, immediately replaced by the next team, already suited up. Equipment is passed at changeover. Medical checks happen in the background. Heat was only the first enemy. But as the TBM drove deeper, the mountain revealed a second, far more terrifying enemy. Raw pressure. Millions of tons of mountain sitting above the tunnel exerted pressure on the tunnel walls that engineers had never encountered before. The mountain was actively trying to squeeze the tunnel shut. In the deepest sections, engineers encountered rock burst. Rock compressed under millions of tons for millions of years suddenly released its stored energy, firing razor-sharp fragments across the tunnel. In the Cedron section, engineers encountered squeezing rock so soft under pressure that it flowed slowly inward like thick dough. A tunnel drilled on Monday would be noticeably narrower by Friday morning. When the TBM cannot safely operate in softer rock, workers switch to drilling and blasting. Charges are placed by hand in a pattern across the tunnel face. After a safety retreat, the tunnel was spoken to. The instant a new section is blasted, workers immediately spray it with shotcrete. Wet concrete is fired from a nozzle, locking the rock walls before they can move. The freshly sprayed section begins to dry, ensuring structural integrity. 12-meter-long self-drilling rock bolts are hammered deep into the surroundings, stitching them together from the inside to prevent collapse. The drill rig pushes the bolt into a pre-drilled hole. A row of bolts reinforces the ceiling. In the most unstable zones, steel rings were installed as an artificial skeleton. Here, a mechanical arm lifts a segment, guided by workers. The completed rings bear marks of the mountain's immense pressure. Precast concrete segments are immediately erected, forming a permanent protective shell. The erector arm press it into position. Workers check alignment, and the joints are sealed. Sensors watch every millimeter. We're installing thousands to catch shifts. In the control room, we monitor in real time. Any movement beyond the threshold, and we act. Water trapped for centuries at 2,900 psi. Inside the Alps, ancient water was trapped in rock fractures for centuries, compressed under millions of tons of mountain, absolutely lethal. When the TBM cutter head punctured a hidden pressurized water pocket, the result was instantaneous. Water exploded into the tunnel at jet velocity. Not a drip, not a leak, a wall of water. At 2,900 psi, the water pressure tore through concrete lining and steel as if it were paper. Engineers described it as equivalent to placing a car's full weight on a single square inch of surface. Construction halted completely. All drilling stopped. For the first time since the project began in 1999, engineers held serious crisis meetings about whether the tunnel could actually be completed. Engineers developed a new protocol, probe drilling small boreholes up to 30 meters ahead of the TBM to detect hidden water pockets before the main cutter head could break into them. Water! Stop the drill! Mark it! When water was detected ahead, engineers pumped freezing liquid nitrogen through small pipes into the rock, freezing the trapped water completely solid before the TBM attempted to bore through it. After freezing, engineers injected chemical grout under high pressure into the surrounding rock, permanently sealing every fracture and crack so water could never again build to dangerous pressure levels. Engineers built permanent drainage channels between the concrete lining and the mountain rock. This gives water a harmless escape path, preventing deadly pressure buildup. The channel directs water safely along the floor. The construction was complete. But engineers discovered one final threat. Real footage shows the test train approaching. Instruments register the shockwave data. 2 parallel tubes, not one. Engineers design connecting cross passages every 325 meters. This allows pressure waves to escape and equalize. Each tube has a single track. Vertical ventilation shafts rise through the mountain. They give pressure waves, heat, and exhaust a vertical escape route. At the portal, large fan units maintain airflow. October 15, 2010, the moment arrives. 17 years of drilling, the two teams are now separated by just one thin wall. The world watched as the final barrier fell. A sissy TBM cutter head pierced through the final rock wall. Light flooded through from the other side. Workers who had never seen each other reached through the gap with their hands first. 3 inches off across 57 kilometers. When engineers measured the breakthrough alignment, they found the tunnel house were off by just 3 inches. For all the strange songs, nowhere to go rest now. At the deepest point, 2,500 meters of mountain sat above the tunnel, the equivalent of 3 Burj Khalifa towers stacked on top of each other. All of that weight pressing down on the tunnel continuously. 28 million tons of rock were excavated over 17 years from the Gotthard base tunnel. To 7.5 into the tunnel, and the surplus built new islands in Lake Lucerne. 57 kilometers. 17 years. 2,600 workers. 90,000 parts per TBM. $12.5 billion. Before the tunnel, a freight train crossed the Alps in 3.5 hours, crawling upward. Through the Gotthard base tunnel, the same journey takes 17 minutes at 200 kilometers per hour on a completely flat track. 9 workers died during construction. 1 in Amsteg. A memorial stands at the tunnel entrance so the world never forgets the true cost of this achievement. Engineered for a 100-year service life with no major maintenance. Swiss precision, every concrete segment manufactured to exact specification. Rigorous quality checks are stacked and numbered. The result, a flawless, smooth tunnel lining. Freight off the roads, into the tunnel. Today, freight trains run at 100 kilometers per hour through the tunnel. Twice the speed of the mountain road trucks they replaced. The most dangerous tunnel ever built. 57 kilometers. Now carries the future of European transport silently beneath the Alps.